Okay, so let's talk about the HMI a little bit. We've taken a look at the factory running and used the manual controls inside the factory, but of course that's just part of the picture. What I have running here now is my Siemens HMI. Now, we could go through it on the screen here, but I think this would be very difficult to see. As you can see, the response is fairly quick, and I've got everything set up ahead of time. But what I'd really like to do is I'm going to show you on my laptop here and run the simulation, and we're going to do screenshots of the simulation for the rest of this video. So let's go over to this, and I'll show you how this works. Okay, so what I have here on my laptop is an exact duplicate of the TP700 touchscreen that I showed earlier. This is WinCC Runtime Advanced, just running in simulation mode. A nice thing about my laptop is it is a touchscreen, which means using the simulation on the touchscreen is identical to using the real HMI, which is kind of cool. Now, this first screen that I'm showing you is the title screen. A lot of original equipment manufacturers like putting title screens on, or the name of their company, name of the equipment, maybe the manufacturer date. Sometimes they put their names on it, but by rights it's a non-value added screen. For all intents and purposes, it's something you could get rid of. I've put it here for educational purposes or for explanation purposes. Most of the time when I get an HMI like that, I'll either get rid of the screen or I'll make it not the main screen, not the screen that the HMI boots up to. Typically what the HMI would boot up to would be this mode selection screen here. So let's go ahead and put the system in automatic mode and do a system start. In the background I can hear the startup alarm going off as the simulation starts to run. Okay, so now the system has started, and this is very similar to what you saw in the panel in the simulation itself, where you had an auto manual mode reset. Now the lights on the bottom that we're showing you, the left, right, and front direction, are simulated by this box weight and direction arrows that you see here. You can see when a box is in position and when the weight is done, and then the weight is displayed in kilograms to 3 decimal places. Underneath that you have your counters, and to the right of that the target number of layers that we're going to stack and how many layers we've completed. I'm going to go ahead and reset these counters. Now I could reset that in automatic mode. You could make that so it will only reset in manual mode or no mode at all, something like that. It really all depends on how you want to program your system. Now I can stop the system and then restart the system. Okay, the startup alarm is going off again, and of course the system's running again. By rights, for automatic operation, that's all you need. Mode selection, system reset, indication of whether a box is on the conveyor, what the weight is, your counts left, front, and right, maybe the number of layers you completed, and that sort of thing. And that's a lot of times where a classroom stops. They get the system to run in automatic mode. They have some basic displays, maybe some selection operation on 1 or 2 screens, and that's about it. What I've done here is created a whole set of manual control and diagnostic screens. So let's take a look at the first one. The first one is the weight control screen itself. So here this is very similar to what you saw in the simulation itself on the panel, where I have conveyor on-off selection via the push buttons. And in this case I have one line above those buttons called the output line, and that says whether indicates whether the conveyor motor is on or off. If you recall, in the simulation I have retroreflective sensors, and I also have diffuse sensors to detect boxes going into the conveyor or going out of the conveyor or on the weight scale itself. This is shown by the in and out tags on the sensor line right above the push buttons. To the right of all those buttons, I've just duplicated again the box weight and direction screen that you saw on the mode screen. And the reason I've done this is because when you're in manual mode and you've jogged a box onto the conveyor, you can see the weight of that box right here on this screen. You don't have to flip back and forth between the mode screen and this weight diagnostic screen. If I now go over to the elevator control screen, you'll see the same controls we had on the panel: raise elevator, advanced clamp, advanced pusher, open plate, that sort of thing. You'll also see the output for those individual controls or solenoids. Now this is a little bit different because for the raise and lower elevator you have 2 signals, one to raise, one to lower. For the advanced clamp, advanced pusher, open plate, you basically only have one output because there'd be indicative to a single-sided solenoid. So the output itself will only turn on when the clamp is advancing, as an example, or the pusher is advancing, or the turn arm is advanced. As soon as you turn it off, then all of those motions return. To the right of that, I have the box feed conveyor push buttons and an indication whether the output is on or off. In this case, we only have one retroreflective sensor to detect boxes going onto the top of the elevator belt, so I only have the one tag labeled in. Heading over to the pallet control screen, I have the pallet feed conveyor, elevator conveyor, and pallet exit conveyor controls, plus indicators to show whether the motor is on or off. For the elevator itself, there is an input retroreflective sensor and an output retroreflective sensor, and a pallet in position capacitive sensor. And I show those indicators on this screen as well. To the right of that is a layer control screen. Now that was back on the main panel in the simulation. In this case, I have it on the pallet control screen instead. If I try to press the up arrow to change the number of target layers, I do get a fault now. It says layers must be set in manual mode only. If you recall, when I did the simulation, when I pressed the up push button, the fault light came on. I couldn't display what fault it was in the simulation, but I can show what the fault is here. If I let go of the button, then the fault message disappears. So that is one way of controlling whether an operator can change something during automatic operation. So in this case, it must be in manual before he can actually select a target layer. Just to show how things can be done a little bit differently, I've also created a settings screen. So let's go over to settings. Now this is a little bit different than layer target control. This requires a password. So I'm going to go ahead and click on the user field, and this is just administrator. And I've left the password as the default 100. Now on this screen, we can change the set points for the boxes. Remember, I said the palletizing box was 3 kilograms, the medium box was 8, the heavy box was left. This is the setting screen to change those. You could hard code it in the PLC, but in general you wouldn't do that in real life. So I've created that setting screen here. The variance plus or minus 100 grams for each of those. Again, the simulation, the boxes actually could come in at 3.001 or 2.99, so there has to be some tolerance set for the weight of these boxes. Now in this case, I cannot set, if I press on the screen here, I tap any of these boxes, I can't get anything to work. And that is because I've disabled that function in the HMI itself. The layer selection was disabled with rungs of the PLC, and we'll show that later. In this case, I've disabled the selection via an HMI mode, and that's a little bit different. So now I've got two ways of showing how you control parameters or set points. In order to be able to change the settings on this screen, we first have to put the system back into manual mode. Now instead of using the touch screen, I'm going to use my mouse at this point. It's a little bit easier to navigate. So I'll have to stop the system, mode reset, put the system in manual mode, go back to the settings screen. Now because we're in manual mode, we can change this. So all we have to do is click on any of the boxes. And as you can see here, I've set the minimum for 1 kilogram, the max for 20 kilograms. So let's go ahead and change this to 2 kilograms. So now as you can see, the set point is changed to 2 kilograms. The variance is still plus or minus 100 grams. And the new set points, or the new window, we're looking for boxes that are 1.9 to 2.1 kilograms. If I change the variance to 200 grams, so 0.2, it calculates a new window 1.8 to 2.2 kilograms. If I try to put in a value that's beyond the set point, let's try 21 kilograms for that box, I'll get a message, value range exceeded, and it will not accept that new set point. Let's go ahead and set this back to 1 kilogram and set the variance back to plus or minus 100 grams. Now, as I mentioned before, the HMI itself manages this information. So you set the minimum for the input field and the maximum for the input field in the HMI itself. And the ability to edit these fields only in manual mode is also done by the HMI, or inside the HMI. Now this is different than on the Pallet control screen, where our layer settings are managed by code in the PLC. So we have two different ways of managing inputs here. From a pure diagnostic point of view, there are all the inputs on the system shown on the input screen. If I press the input button once, I get the first set of inputs from I2.0 to I7.7. If I press it again, I get the next set of inputs from input I8.0 to input 13.7. The button is changed to inputs A. If I press it again, it just toggles back to the first screen. Similarly with outputs, it says outputs A. I'm going to press that, and I'll get the first set of outputs from 2 to 7. If I press it again, I get the outputs from 8 to all the way through 13.7. This relates to the flat menu concept I was talking before, where you can get to any screen from any screen. You notice no matter where I am on these screens, I can go back and forth at will. It doesn't matter what screen I'm on. It does default to inputs A and outputs A, but from a diagnostic or operational perspective, that's not a big deal. In some cases, we have page up and page down to go through the input screens and the output screens if there's many of them, or a menu selection of some sort within that screen. But it still allows you to jump back and forth between the menus without having a sub-menu causing a lot of confusion. I'd like to point out one difference, or one of the differences between an input diagnostic screen and, say, a weight control screen that has manual operations and some more diagnostics on it. If you take a look at I3.6, I3.7, and I4.0, those are the proximity switches looking at the boxes coming into the scale itself, or onto the scale itself. If you notice, I3.6 is mostly on, where I3.7 is mostly off. That's because I3.6 is a retroreflective sensor, so when the box is not there, it's on. And when the box passes the sensor or the input turns off. So in this case, I've shown the real status of the inputs themselves. If I go over to the weight control screen, if you take a look at the scale conveyor in and out, well, they're mostly off. That's because I've reversed the logic for those tags, because in this case I actually want to show whether the box is being detected, not the status of the input, so it's a little bit different. So what have I not shown you yet? Okay, well that's, the alarm screen. So let's go over to the alarm screen for a second. As you can see, there are no active alarms on this screen. I'm going to create an alarm in a second and show you how that works. If I go over to the alarm history screen, there must be a memory card on the HMI for the alarm history to function. You have to send that information to a memory card for storage. As you can see, I've been creating faults and testing the system. I have box stuck on left conveyor fault, box stuck on scale fault as history, but they're not active. If I click on one of these, let's say box stuck on scale fault number 4, and press the text button, I also have text in the system says occurs when a box is detected by the left conveyor entry limit, but then fails to trigger the exit limit within the specified period of time. This fault will clear once the limit is triggered. So all the faults have information text associated with them, all entered into the HMI. Let's close that box for a second. I'm going to let's go back to the weight control screen for a second, and I'm going to go ahead and create a fault here. So a palletizing box is going on to the palletizing conveyor, and I'm going to pick it up and throw it off. Okay, now I get a fault saying the box is stuck on the right conveyor. Now I've made all these faults self-clearing and I don't stop the system, okay, but that's just for the simulation. In the real case, you'd probably want to stop the system, flag an operator to come over and clear the box fault. If I head over to the alarm screen, I can see an active alarm, box stuck on right conveyor. If I hit the information or click on the fault and then press the information icon, I get the information text saying this occurs when a box is detected by the right conveyor entry limit, but fails to trigger the exit limit within the specified period of time. This fault will clear once the exit limit is triggered. So again, I don't shut the system down. They're self-clearing faults. Next time I get a palletizing box passing the exit limit switch or proximity switch, that fault will clear. So hopefully you get a palletizing box pretty soon, and I can show you that fault clearing. And it's just my luck, we're not getting a palletizing box. The emitter, just FYI, is random, so it randomly creates boxes. And right now it doesn't seem to want to create a palletizing box. Okay, here it comes one. So a palletizing box is coming up to the weight scale. It's being weighed, and it's going to send that right, and that should clear that fault once it exits the conveyor. Okay, now that fault is cleared. Hopefully that gives you an idea of what a real HMI would look like and how it would function on a factory floor, and why this is so difficult to do in a classroom setting. In order to create all these screens, all the input screens, all the output screens, the weight control, pallet, mode operation, elevator control, that is a lot of man hours to create it. Not only do you have to create the tags, but you have to create the graphics on the screen. For the inputs and output screen, as an example, every one of these tags has to be placed on the screen. Every one of those inputs has to be typed in. Every one of those description boxes has to be typed in. On the alarm screen itself, let's go over to alarm history for a second. Every one of those alarms has to be typed in the system or imported via file, but someone has to create all these alarms. If you click on alarm and bring up info text for an operator to allow them to clear a fault or give them specific direction, all this has to be typed in. So you're looking at a lot of man hours to create this, something that you wouldn't necessarily do in a classroom environment. But this is what you would see if you went out into the field. So basic operation, let's go back to the mode screen. Basic operation where you have automatic mode, system start, maybe some display functionality. That's fairly routine and fairly easy to put in a system. It doesn't take a lot to get a system to work into automatic mode. What takes a lot of time is to add manual functionality, to add fault, messaging, help screens, diagnostic screens, setting screens. That takes a lot of time. So if you start with this kind of system and say, give this to a student and say, here's what a real system would look like. Once you've taught them the basics, you can show them a full-blown system like this, or a simulated system, and say this is what you would get in a real factory. Well, hopefully that gives you a little bit of insight into how much work and how much detail goes into creating a real HMI, and not just some basic operations. So again, that's the Siemens TP700 HMI and the S7 1200 series PLC that's running the whole factory.